your notebook ready. So there are, I also gave you the videos that Professor Supe uploaded in the YouTube. So you can see that, but it's just an introduction. So Python has many things, and you can learn it by searching it online and can see what other functions you can use. First thing is this, and second thing is that uh, after doing this, because it depends on what is your problem statement, what you want to do. So that depends what you are going to write in the Python. So regarding this, there are so many different documentation in Python, like Pandas has its own documentation, then NumPy, and there are so many documentation, even sklearn has its documentation. So you can go to their documentation, or there are different websites that will give you some idea regarding, like this Python W3 schools. It has Python introduction, syntax, and exercise. And try to, I will say, just to take a small project in hand and just try to uh, see if you are able to learn more and more, because if you are going to just memorize things, you will not be able to memorize all the codes. But if you will do different projects, you will be able to memorize it because of the practice. So that is the second thing. And Python is right now very important. Most of the projects has been done using Python. R is also good, but it is more of statistical tool. So it's best idea to be um, to learn Python beforehand. And after this, you can see that there are many tutorials. You can go anywhere from here, Python tutorials, and you can get. But in my understanding, you can get the idea from the tutorials, but the best thing to do is go through the documentation, because the documentation has many things that you will not be able to see in that tutorial. So if you are just thinking there are so many things, but you are not going to learn everything, because it's a wide language, so there are so many options. But data science uses particular few things, so we are not going to learn everything from here. But yeah, we should see what particular we can learn from it. So I just want to say, what is Pandas, what is NumPy. So there are, either you can write codes from scratch, or there are libraries or packages that they have their own codes, and you can install it and use their codes. Like Pandas is very famous. What is the difference in between Pandas and NumPy? Pandas is mostly like reading your data and doing your, it will create a data frame, and you will do your analysis and further reportings um, and visualization from that. But if you are going for some mathematical derivation, something, whatever you are going to do, you have to use NumPy. So that is the main difference. But there are so many packages like sklearn. Right now in machine learning, it's very famous. And after that, there are stats models. There are many packages. You can see it online. As per your requirement, you can Google it and can get it. And after this, I will like to show you one more thing. And that is, after going through this, I just wanted to show you this thing. And here, so here we can just get all the cells, like plus like this, or we can do simple steps like escape and B to get the lower cells, or escape A to get the upper from there. So that kind of small things. And here we can see that here it's written code, but if you want to change it markdown, it will change to markdown. So if you are going to write, so now it is like this. So either if you are going to start a project, you have to give some idea to yourself or to your professor that what you are going to do. So this is kind of thing you can do in your notes. And after that, if you want, you can use comments in the here section, and we just use, we can write it like this. Any comment can be written, and every time you have to just put this hashtag. So after this, there are many methods, and in the other video you will learn few methods there. But I just wanted to tell you the different sources from where you can go ahead to start. First thing is Jupyter Notebook, but this is system based. So if you are going to use pandas, you have to use your system, that is you are going to go to your CMD like this, and then you will write pip install. It's already been there, so it will write this. And second thing is that if you are going to install pip, just go for pip, or if you are going to install conda, don't install both of the things, because it's better to go with either pip, either anaconda, and there's no particular preference. But sometimes some people think conda is better, so it's your choice. But I generally use pip, so I never had any problem. And second thing is that after a while you are not going to use your system much, so now there is a, you can say, pattern of using your uh, cloud system. So what we can do in the cloud, we have so many things. So first I will go with the very simple, and you can try it in your own system. You are going to write the Colab, whatever you Google account you have, you just going to write Colab. So this will give you the this kind of file. So I think here we will go and create new notebook, and from here you can see we can give the name and everything. So it is similar to uh, our system one, what we are using earlier by installing pip and other packages. But here we don't need particular, because it is in the cloud. Like there are some libraries that need different graphical approaches, so you are not able to download, or if there is any problem. But in the, if you are going to use the Colab, because it's in the cloud, so you don't need to download here. If you, there is no program, so you are going to write here to pip install, so it will. But normal packages like pandas, numpy and sklearn, you don't need particularly that to install here in the Colab. So I just created that, you did already in R, so I just created this. Now, whichever account you are going to use, like this is your school ID or any Gmail ID, because if you are even going to use your personal ID, you can use Colab in that too. And this is free, so you have not to give any, you have not to spend any money in that. So from here we can understand how to do work here. You can do the similar work in your from your system by using this Jupyter notebook, but you have to keep in the mind that you have to install pip install pandas, pip install different other packages before doing this exercise. So first thing, this is a Colab notebook, and we have to uh, just mount our drive, that is a Google Drive. So this is the code. There are different other codes you can use, but this is the code that will work. So you can start with running it, and here it will ask for the authorization. You will click that link, whatever account you are using, go with that, and every time you are going to use, it will give you the different code. So after this, you are going to paste it, Control V and enter. So now this notebook is connected to your drive. It will take some time, but it's like 20 seconds or something like that. After that, like we were doing in the CMD, similarly we can do changes in the drives, and we have to write %cd and the location where you want to take your this file. So I wrote this because you can go to your drive and can see what's there, what folder you can create and give name. So you can write it here. And then I imported pandas. So I ran this, and now we are going to read it by, because generally either you can write it as import pandas as PD, or you can just write import pandas. And the only thing is that instead of PD you have to write pandas. So it's better to write something smaller because you have to use it again and again. So now we will run this to get our data. Now we have our data. Now there are simpler things you can do with this, like you want to see what's in the data. So you are going to use df.head. So in the head it will give you 5 rows. So this is your data. And the best thing is Colab gives you, when you write df dot, so it will give you the all the functions that you can use with it. And similarly Jupyter Notebook also gives, but for this, when you just put dot, you can get these all options. But for Jupyter Notebook, what you have to do, you have to press tab. After writing, you have to press tab and it will give the options. So it's a better idea if you want to see what options or what other functions you can use. So you can go ahead with that. Like we can see it's dot, so we can see what function we can use here. So we can go ahead, because there's so many, as I told you earlier, there's so many functions. So we can just go ahead and see if we have, like here we got the shape, so we can select from here and we can run. Now it's telling you have 20 rows and 2 columns, and then df dot, then again it's going to give you every function you can go ahead with. See what other, like here describe, so it will let you know what is in the data. So here you can see here count, mean, standard deviation, minimum, and all other 5-point summary, and of all the variables. So it will give all the variables but not the categorical variables. So all the quantitative variables you will be able to get that. But if you want to get all the information, you can also do info. So this, when you are going to write info, it will also let you know what type of data you have and if you have null values or not. So from here you can learn that, or there is one more option, that is gf.isna. So we can use that too, but now we know that we don't have null values, so we don't need to do that though. But generally we can do this. Now, if you are going to write just df.isna, so we are going to get it in the Boolean, like false, true, but this would not be a good idea. So what we can do sum. So now it's showing you there are no null values. So after this, after the initial inquiry of your data, you can go further and you can see how you can plot it or you can visualize your data. So you can go ahead, and this is the different library known as matplotlib, and this is for visualization. This is the basic library, but there are so many libraries like Cborn is there and Bokeh is there, and now Plotly is free. You can go ahead with Plotly. So there are many options. So, and again, if you are going to use Cborn or any visualization package, just go with their documentation and see what's going on, what are the options, and what you can learn from there. And now I just got this, so I am going to run this program, and what I can see here, we got the similar plot we made, I think, in R. So here we can see that this is a scatter plot and this is showing. But if you want to change the color, what we can do, we can just write color, or green, or any color. There are different options. You can see what there are many options. So you can see what options you can use. And for size, if there are 3 variables, you can use size too. And after that, there is a option for alpha, and it is value from 0 to 1. So it is nothing. You can see it takes your visualization, your scatter plot, from transparent to opaque, just that. So if you are going to write 0.2 here, it's light. If you are going to do 0.8, it's darker. So it's your choice what you want to see in that and how you want to visualize it. So it's completely on you. And like plg.show we did, this is the code for our visualization. But we can also write, because there is no title in this, so we can go ahead with scatter plot, or you can give any name, any title. Similarly, we can use names for our x axis and y axis, but that would be much more, and there are so many visualization, there are so many different options, so you can explore it later by yourself. So I am going ahead from here. So after this, what we are going to do now, we are separating our x and y. What is x? We already know, that is the independent variable, and y is our dependent variable. So we will write it x. There are two options, that is iloc and loc. So right now, just if you are going to use .loc, you can write the name of the variable, but if you don't remember the name, that is iloc. And here you can write write like this, and you will get you are just getting your variables, and you get x and y. And one more thing is there, that we are using dot values and we are changing it into arrays. If you are not going to write dot values, it will still be in the data frame. But because most of the packages use arrays and for the analysis, so it's must to change it into array. So, and particularly if you want to see what's here, and after here you want to see what's this, so you can write x dot here. We can see numpy dot nd array object has no attribute info, because now it's not data frame. So we cannot use pandas functions. So here we can understand it, or we can see by other means too. But now I will go ahead and will show you how we can split the data. You learned already in R that we split the data, because why we split the data? Generally, just try to take it as if you have 100 people somewhere, and you want to learn something. So you are going to get 80 people or 75 people, and ask them few questions. And after that, you got to some conclusion, or you got some equation. And after that, you want to see uh, with the remaining 20 people, that if what you learned from the 80 people, is that implying, or what result you are going to get from the 20 other people, because that 20 people we are not using in our study. So we have to keep in the mind that first, after getting x and y, we split the data. But in the Python, we have option train test split, and this is very nice, because we can get our training data in x underscore train and y underscore train, and x underscore test and y underscore test. And for training, we are not going use to ever our test data, because if you are going to give the information of test to the training the model, it's not a good idea, because you are using all the information in your modeling. So it's not going to give you the real results. So it's the best idea to go like this. And after this, you can use test size, like you can go ahead with anything you want. And random state is just the seed. We set a seed, like I don't want to get the split every time and with different numbers, different rows. So what I can do, there is an R, that is set dot seed, and here we use random underscore state, and you can give any value. This value has only significance that every time you are going to write that random state, it will take the similar data in all these sets. So we can go ahead and write this. Now we got our x train x test, and if you want to see our, you can see what's in there, you can always see. So it is like this. So we now have the idea what's there. And similarly, we can go ahead with x test y train. I will show you y train too. Yeah, here it is. So now we have a idea what we are going to do. Now we are going to apply linear model, that is linear regression model. So here it's linear model, and the best thing is that uh, I'm using linear regression, but if you don't want to, there are so many different options here. So if you are going to see, so right now it's not giving the option, but there are many options like Lars, Lasso. There's so many options you didn't learn yet, but you will learn them in the future. So right now I am going to do it as linear regression. So here it's linear regression. That is linear model. Here we are importing linear model, and from linear model we are getting the linear regression, and we are going to run this. And after that, we got this in reg, and then we will use reg.fit x train y train. And it's just I'm doing control enter. So either you can do control enter, or just you can run from here. So you can do this, or if you want to delete something, you can do like this. And if you go ahead like this, you can get a code cell above it. And if you want to write some text, you can go ahead here, and here you can see that there are options like, here you can see it's showing. So this is similar like what we saw in our Jupyter notebook in the system we were using. So this is the somewhat different, but not a lot. So after this, if we want to see what's the score we are getting from X train and Y train. So we got 0.89. And after that, we are going to predict our X test. So here we can see we got our prediction. And after this, I will say that just go ahead with the model and write dot, and here we can see the options. So no, there are many options here, so we will go with coefficients. So there is a coefficient option, and here you can see you get your coefficient, but that is because we had only one variable, so we got that. And after this, we can also get the intercept. So for this, we can get like this. And if you want to get the score for X test and Y test, you can get it too, because I think I downloaded R square, so you can use that. And this is this everything what I am doing, you can get it from uh, documentation of the sklearn. So you don't need to think that you are going to write everything, but you should understand what you are doing and what why you are doing that thing and what results or what is your problem statement you are solving here. So you can, I think, do this thing. I don't use generally this, so but see what we are going to get. Yeah. So here it's giving you the value for the prediction that we got from the X test. And here the thing is, we are not going to give it Y here. We are just giving an X test. Here we use the model. It got trained here. And after that, we are predicting our test set. And when we got our test set, that is the predicted values, we are just comparing it with y-test, and it's giving the score that is 0.79. Earlier it's 0.89, so your model is kind of a bit overfitting, not a lot, but that is reason we do training and test. And you can see it's 0.79, and still it's good. So I think this is the whole thing I just wanted to tell.